Hello everyone. As usual, please go to the polls tab and let me know which problem you want me to do today. So far, I have sent two responses. One is for problem 7, other is for problem 4. Okay, so you keep taking this poll. So far, as of now, there are more votes for problem 7. So 5 people wanted me to do problem 7. So let me begin with problem 7, then I will come back and see which problem is the next. Okay, so what does it say? It says that lifetime in hours of certain kind of radioactive is a random variable having a probability density function given by some function. Okay. Um, if is given by let me write that down. If x which is 0, if x is less than equal to 100, and this is 100 over x square, if x is bigger than 100. Okay, so if I draw the picture of the probability density function, um, is going to look like, so this is the point 100. So it is 0 up to 100, so it stays at 0 up to 100, and at 100 it goes up 100 over x square, and then as x increases it is going to go down, something like that. Okay. So now what is the question? The question is, what is the probability that exactly two of such tubes in a radio set will have to be replaced within first 150 hours of the operation? Okay, so is that two out of five such tubes replaced within first 150 hours. Uh, First of all, you would like to answer a simpler question. Which is what is the uh, probability that a particular tube be replaced within first 150 hours of its operation. Okay, how to find this? So let this probability, let the probability of the above question so our first step is to figure out this period. So let us first what is this little p? Little p is the probability that for a single tube will go out of operation within 150 hours, right? So if I do the calculation, it's going to look like okay. So it's going to look like from the previous day's lecture. So this p is going to be the probability that the random variable x is less than 150, which by definition from the previous lecture as well, it is integration of negative infinity to 150, and you integrate the probability density function fxx dx. Okay. Now the probability density function is 0 up to 100, so you can safely ignore the integration up to 100. You can start the integration at 100 up to 150, and then there the density function is 100 over x square. Okay, from here you see that it's 100 over x square. This is going to be 100 over x square dx, so which is negative 100 over x, 100 to 150, that is 1 minus 100 over 150, which is 1 minus 2/3, that is 1/3. Okay, so what is this quantity of 1/3? So 1/3 is the quantity that that the probability of a particular tube, or probability of any tube, will has to be replaced in first 150 hours. Okay, but that is not the original question. Original question is what is the probability that 2 of 5 to be replaced by this, right? My first comment, next comment is that this is like a binomial model, because it is also given, right? So it is also given that the events are independent. So it is given that the lifetime of each is independent of other. By the way, I have not asked, is my screen clearly visible, or am I clearly audible? Is there any sound or video problem? Because yeah, I don't know if this internet is even working or not. So can someone say if I'm audible or visible?
Yes.
Okay.
Yes, sir.
Okay. So okay. So the original question. Okay. Original question is that to find the probability of 2 out of 5 will burn out within 150 hours. What we have found in the first step is the probability that a single tube is going to burn out within 150 hours, right? It is also given that the lifetimes of these tubes are independent of each other. Now, this should imply, so the thing is that you can identify this with binomial model. How do you identify this with binomial model? Think of what is this? Okay, think of burning out of a tube as getting head from a coin toss. Okay, and survival of a tube. It's like getting from a coin toss. Now, what we have figured out that this probability, okay, in the first step, this probability is 1/3, right? Burning out of a tube within 150 hours is 1/3. It's like getting a toss is 1/3. So therefore, survival of this tube has probability. That's just like tossing a coin. And probability of success is 1/3. Failure of two is 2/3. Then the original question can be translated to the following question, which is probability of getting hits out of 5 trials, right? So if I look at the original question is asking what is the probability that 2 out of 5 such tubes have to be placed, which is like getting 5 heads out of getting 2 heads out of 5 trials. And how do you do that? So this answer is very simple again. It's again the binomial model. So the answer is, okay, answer to the original question is going to be 5 choose 2, 1/3 square, and then 1 minus 1/3, which is 2/3 cube, right? Because recall that if you have binomial random variable x follows binomial NP, right? Then probability of x is equal to k is going to be n choose k, p to the power k, 1 minus p to the power n minus k, right? So this was the binomial model, and we answered this question using that binomial model. Does anyone have any comment, concern, remark about this solution? Otherwise, I will move to the next requested problem. So problem 7 was requested by 13 people. I have just solved it. And what is the next one? Next one is problem 1. Okay. 5 people have requested that. So what is this problem about? Okay, it says that there are 5 men and 5 women who are ranked according to their scores on an examination. Assume that no 2 scores are alike and all 10 factorials possible rankings are equally likely. Let x denote the higher ranking achieved by a woman. Okay, so my first remark is that this problem is similar to the first example that we did in the last class. So how is that? Okay. So what was the previous day's lecture? Yeah, so this is the problem. So previous day we did a problem. This was the first example we did. That there are 3 blue balls and 4 red balls. Think of those like 3 boys and 4 girls. You keep picking the balls at random without replacement until you get a red ball, right? Think of this as like you look at the rankings and you scroll down, or you like see down to the ranking until you see a woman's name or girl's name, right? And let x be the variable which denotes the total number of trials you needed, which means in this case, this x would be the rank of the girl, right? So do you see the similarity that this problem in example 1 that we did yesterday was you keep picking ball until you see a red ball, and here you can think of like there is this merit list published, and you look from the top, and whenever you see, so it's like first one is a boy which is like blue ball, second one is a boy which is blue ball, and once you hit, let's say like third one is a girl, and that is like a red ball, and you stop there, and your variable value is going to be 3. And that's exactly the same problem this example 1 is. Okay. So one remark here I would like to mention that picking up items without replacement is important. Picking up items without replacement from a bin of n items is equivalent to ordering the items at random. Okay, so this is the crucial observation for this problem. In this problem, it is saying that the boys and girls are ranked according to their scores, and which is a similar phenomenon. Like boys and girls are put in a bin, and you pick them up at random. Whoever comes first, you rank them as like first rank, and then whoever comes second, you rank them as the second rank, and so on. So now let's complete the solution of this problem. So here x is the original question. X is the highest ranking achieved by a woman, right? So x is the what are the possible values of x? By the way, it is given that there are 5 boys and 5 girls, right? So 5 men and 5 women. Alright, so what are the possible values of x? First of all, that we need to figure out. Possible values of x could be if so you are reading of the merit chart. If the top ranked person is a woman, so it's 1. That's the lowest possible value of x could be. Or you can find the top ranked woman in the second list, or maybe third list, or maybe fourth, maybe fifth, and that's all. You can never go beyond 5. Okay, the highest rank of a woman cannot be more than 5, because at the worst case, what might happen is like all 5 women are at the bottom 5. Even in that case, the highest rank achieved by a woman is 5. Oh, sorry, that is actually going to be 6. Highest rank achieved by that woman. Yes, if the worst case is that all top 5 are boys and all bottom 5 are girls, then in that case the highest rank is going to be 6. Highest rank of a woman is going to be 6. Okay. So how do you figure out the probabilities? Again, I'm going to take the same approach as I did in the yesterday's example. So let us define these events. Okay, this event bi. If you try to find similarity with the previous day's example, it will be even more clear. So bi is the event that the ith rank is a boy. Okay, or is a man. Okay, and okay, let me list that. Let mi and wi is the event that ith rank is a women. Okay. Now the event that probability x is equal to 1 is nothing but the first rank is achieved by women, which is probability of W1, which is probability out of 5 women, out of 10 people, and there are 5 women, so the chances is 5 over 10, which is 1/2. Probability x is equal to 2 is going to be the fact that the first rank is achieved by a man, which is M1, and the second one is a woman. So again, applying the technique from previous test lecture, it's going to be probability of M1 times probability of W2 given M1, and that is going to be, so probability that the first rank is a man, which is 5 over 10 times, given that the first rank is a man, so there are now 9 people left. What is the probability that the second rank is a woman? There are 5 women left, so it's going to be this 5 over 9. Let me do one more, and the rest of those will be actually similar. So probability x is equal to 3 is the fact that probability the first rank holder is a man, second rank holder is a man, and the topmost rank holder, woman rank holder, is the third rank holder, which is W3. So again, if I split it up using law of total probability, a law of the product of the probability, is going to be probability of M1 times probability of M2 given M1 times probability of W3 given M1 M2. So probability of M1 is 5 over 10. Probability of M2 given M1, which is saying that out of 9 people, the first person which we picked is already a man. What is the probability that the second person is also a man? There are 4 men left, so it's going to be 4 over 9. And the last one, out of 8 people, we want a woman. There are 5 women left, so it's 5 over 8, right? So on, right? You can do these kind of calculations like the previous day's lecture. So probability x is equal to 4. It's going to be, I guess, the first person is a man, which is 5 over 10. Second person is a man, which is 4 over 9. Third person is a man, which is 3 over 8. The last one is a woman, which is 5 over 7. Okay, and so on. Okay, so we can figure out other two. And actually, let me write it down. So x is equal to 5 is going to be 5 over 10. First person is a man, and second person is also a man, which is 4 over 9. And third person is also a man, which is 3 over 8. Fourth person is also a man, which is 2 over 7. And final one is a woman, which is 5 over 6. And the last one, probability x is equal to 6 is going to be the same sequence: 5 over 10, 4 over 9, 3 over 8, 2 over 7, 1 over 6, and 5 over 5. That's it, and this is the end of the story. Okay. Any question about this problem, this example 1?
Yes, sir. Sir,
yes.
One question I need to ask you, sir. Sir, what should we write as the, sir? As in the question, it is written that one that we have to find that p of x equals I. Suppose let that I is equal to 9 or 10. Suppose it is 10. So what should we write that one?
So for I is equal to 10, you just write 0.
Okay, sir. But sir, I think, sir, if we are summing that probability of x equals 1 to x equals 6, the full probability, so I think it is not giving 1. So somewhat less than 1 it is giving.
It's not giving 1. So if you sum of the probabilities that I have written here, right? So starting from here, so for 5 over 10, 5 over 10 over 5 over 9, and these probabilities, if you sum this up, you are not getting 1.
No, sir. Sir, I may be wrong, but I to check twice and I am not getting. So I
that is okay. So I have not checked that, but it should be giving you 1, because if you follow the same logic as this example 1 we did in the last lecture, it was 4/7 plus, this times this. So I, first of all, what I did in the previous lecture, I made all common denominators here for all the probabilities. Okay. So the way to calculate this is going to be, you make a common denominator here. So for example, write all the probabilities in this format. So write this as this bottom part is going to be 10 times, 9 times, 8 times, 7 times 6. So for all, right? And for this top one is a 5 factorial for this one, right? This is 5 factorial, and this bottom one is 10 factorial. Like whatever it is, I don't know how do I write this, like 10 times, 9 times, right? So 6. My point is that whenever doing the calculation, try to write this thing for all the terms, right? So like here the 6 is missing, so you can write here like like 6/6, something like that. Okay, and make common denominator, and it should be actually match up. I will check. Yeah. Any other question? Okay, so what is the next requested problem? 8 and 4. Problem 8 was actually, the exact same problem was done in the previous lecture. So let me actually mention that. Problem 8. So some of you have requested problem 8. Problem 8, I would say, let's see the last problem or the final problem. On the previous day, we did a problem which is like totally identical to this problem 8. The final problem that we did yesterday was this one, where I gave you a PDF with some unknown constant. So I gave you a PDF with some unknown constant, and how to figure out this unknown constant? You have to find, you have to use the fact that integration is equal to 1, and that's how we find the unknown constant. And once you find the unknown constant, you can figure out the probability of an event, but just by simply doing the integration. Problem 8 is exactly the same thing. So in fact, I did this problem in lecture keeping the problem 8 in mind. So if you understood that, you should be able to do problem 8. It's very straightforward. Okay, problem 4. Some of you have requested problem 4. Let me see what this problem is. This has a long distribution function. And some description of distribution function, it is asking what is the probability of this, probability of that, and so on. So let me start this problem. Excuse me. Okay. The CDF in this problem is given by this fx uppercase f. Why am I writing in blue? Okay, so this is given as 0 if x is strictly less than 0, and then x over 2 if x is between 0 and 1, strictly less than 1, and then 2 over 3 if x is between 1 less than or equal to x, strictly less than 2, then 11 over 12 when x is greater than or equal to 2 but strictly less than 3, and 1 when x is bigger than or equal to 3. The first part of this problem is asking you to draw the picture. Okay. Even if the problem did not ask you to plot, it is always a good idea to plot the picture. Okay, so let's plot the picture. Okay, the first domain is less than 0, so we don't care about that. So when less than 0, it is 0. Okay, and from 0 to 1, so let me mark those points. So 1, 2, 3. Okay, so from 0 to 1, it is x over 2, and so which means at 1 it becomes 1/2. Okay, so let's mark this point 1/2. So this is like say 1/2. From 0 to 1, it is x over 2. Okay, so I kept it open. If you look at this right side, right? If you look at this right side, I kept it like an open ball because here it says that when x is strictly less than 1, up to there it is x over 2. So 1 is not included. Okay. Now when x hits 1, it goes up, bumps up to 2/3. So this height is 2/3. Let's call this height 2/3. I put a solid mark there, and this goes till the number 2, but 2 is not included. So I put a open ball there. Okay. And then from 2 to 3, it is 11 over 12. So at 2, when it hits 2, it bumps to 11 over 12. So let's call this point 11 over 12. And then it stays flat up to 3, but doesn't hit 3. So I put an open ball here. But once it hits 3, it bumps up to 1. So this height is 1. And it stays at 1 forever after 3. So that's the picture. Now what is the next part? Next part says find the probability x bigger than 1/2. So probability of x bigger than 1/2. Okay, which is you can write as probability 1/2 strictly less than x less than equal to infinity. So why do I write less than equal to, which is stupid? It can never be equal to. It's strictly less than infinity. Okay. Which is the distribution function evaluated at infinity minus the distribution function evaluated at 2. Evaluated at 1/2. So I'm writing 2. So if fx at infinity is 1 minus fx at 1/2. What is fx at 1/2? So this 1/2, this is going to be 1/4, right? So this is 1/4, which is 3/4. That's the answer for the first part. Part C, which is okay. What is the probability that 2 strictly less than x less than equal to 4? Again, from the previous test lecture, it's going to be if x 4 minus if x 2. By the way, let me remind you this thing. So although you should know from the previous test lecture that the fact that we have been using that probability of x strictly, hold on. So probability of A strictly less than x and less than equal to B is given by if x B minus if x A. Okay, this is what we have done in the previous day's lecture. Mark this, where we have strictly less than, and on the right side I have less than equal to. Okay, the next thing that we did, that probability of x is equal to any particular point B is if x evaluated at B minus fx evaluated at b minus, which is the left limit of the function. Okay, so we're using that thing here. So fx4, okay, what is fx4? fx4 is 1 because it says that whenever x is bigger than 3, it is 1. So fx4 is 1 minus fx of 2, right? So yeah, fx of 2. What is fx of 2? It says that fx at 2, when x is equal to 2, it is 11 over 12. So fx at 2 is going to be 11 over 12, which is 1 over 12. That's the answer. Part D, it says what is the probability that x is strictly less than 3? Okay, probability that x less than 3. How do you do this? There are multiple ways to do this. I am just going to do this in a direct way, which is negative infinity less than x less than equal to 3. So I'm putting a less than equal to here. Okay, which means it was originally strictly less than. I'm including the 0.3. So because I want to match up with this formula, but to do that I have to adjust this. So I have to subtract probability x is equal to 3. Okay, so I have to subtract that so that balance out. So this is going to be fx3 minus fx negative infinity minus probability x is equal to 3. What is probability x equal to 3? That is fx at 3 minus fx at 3 minus. Okay, now fx3 is 1. Okay, fx3 is 1. If you again see the description of the problem, it says that when x is equal to 3, it is okay. So it is equal to 1. When x is equal to 3, it is equal to 1. So that's why I put 1. Okay. Now fx negative infinity is 0. You know that. Minus fx3 is also 1. And fx3 minus is essentially right before 3. What is the point? Okay. So right before 3, if all the way up to 3, it is 11 over 2. So fx3 minus is 11 over 2. If you look at the picture again, right? So if you look at the picture, when you approach 3 from the left side, you stay at 11 over 12. So the limit there is 11 over 12. So this is 11 over 12. So the answer is 11 over 12. Okay. And the last part, which says probability x is equal to 1. So probability of x is equal to 1. Again, the same formula, like this formula, probability of x is equal to any particular point is going to be that if x evaluated at 1 minus fx at 1 minus, so the left limit of 1, right? So 1 minus, which is, so what is fx at 1? Let me check. Fx at 1, so when x is equal to 1, it is 2/3, and at 1 minus, if you approach 1 from the left side, you reach 1/2, but at 1 it is 2/3, so it is 2/3 minus 1/2, right? So it is 2/3 minus 1/2, which is 1 over 6. That's it. Okay, so this was problem 4. Any confusion up now? By the way, the quiz is actually live now. So if you, so let me see if anyone has any more question. After that, you can start taking the quiz. So I have answered problem 1, 4, and all the requested problems 7 and 8. And problem 5 is the same thing as 1, 4E, which I have also answered. All right. So does anyone have any more question about the material or the homework or anything?
Sir, I cannot see any quiz over here.
You go to the assignment tabs, right? So you go to the assignment tab. Where's that? The usual location, right? So you go to the assignments, and you should be able to see this thing, right?
Yeah,
So
now it has come. Now it is.
yeah, it was supposed to live at 3:10. Yeah, so it is 3:10 now. Okay. Yeah, so you start taking the quiz. You have like 15 minutes or so. So once you are done with the quiz, you may leave the session as usual.
Sir, can we leave?
Yeah,
Oh.
if you are done, you can leave. And also, this form may stop taking responses after 5 minutes. Uh, those who have not submitted yet, please do it fast because this form may close at 3:30. So you won't be able to submit after 3:30. And if you are done, you may leave. So if you are done, you may leave the session. I'm going to close the meeting after 2 minutes.